Hello, pre-calculus students. Let's review what we learned in section 9.2, part 1. We were doing hyperbolas with the center at 0, 0. So just a quick review, we had our vertices are A units away from the center. The covertices are B units away from the center, and the foci are C units away from the center. The formula to find C is C squared equals A squared plus B squared. And so when you look at the equation of the hyperbola, you determine whether it's going to be horizontal or vertical by looking at the first term. And if the first term says x squared over a squared, it's horizontal. If the first term is y squared over a squared, it's going to be vertical. And so what we did next was find the vertices by finding a, which is under the x term, so that makes the vertices value in the x location. So you have to put the 4 in the x place, and then covertices will be the y value. And you use A and B to find C, and then C are aligned with the vertices, so they are also along the x-axis. Part B here, we saw that it was a vertical hyperbola, so the vertices will be along the y-axis, so you put those in the y value, and the covertices will be in the x value, in the x-axis, and the foci, let's finish that up there. I think it got deleted here. X squared equals 20, C squared equals 25, so C equals 5. So the foci are 5 units away from the center, and since they are aligned with the vertices, then the foci are also along the y-axis. So we're going to name these points as 0, -5, and 0, 5. So having all this information, we can start to graph, and we'll graph the hyperbola in just a few minutes. Next, we're going to find the equation of a hyperbola from its foci and vertices. So remember that foci are C units away from the center, and vertices are A units away from the center. And so if we know A and C, we can figure out B, and then plug that into the equation of the hyperbola. So in this example, we have foci being 3 units away from the center, so C equals 3, and the vertices are 2 units away from the center, which means A equals 2. So just first thing you want to do is solve for B. Copy down our equation for figuring out A's, B's, and C's and how they're related. A squared plus B squared equals C squared for hyperbola. So 9 equals 4 plus B squared. And so B squared equals 5. And we're going to leave B squared just like that because we need B squared in the equation. So we know this is a vertical hyperbola because the foci and the vertices are on the y-axis. The values of those points lie on the y values, so it's a vertical. So the equation for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. And all we have to do after this is just substitute. So we end up with y squared over a squared, which is 4, 2 squared, is 4, and then minus x squared over b squared, which is 5, because we calculated that earlier, and then set it equal to 1. Okay. The asymptotes are those lines that the hyperbola approaches, and how it curves towards those lines. I gave you guys the equations for the asymptotes. There they are. So when you have a horizontal hyperbola, it's plus or minus b over a x. So, and then the vertical is a over bx. And you can see that in the diagrams below. So look at the asymptotes. There they are, the negative and the positive asymptote. Positive here, negative here. Positive and negative asymptotes. We need the lines to cross in both directions. So to graph a hyperbola, I've given you some steps here. First, you locate the vertices. And then you use dashed lines to draw the rectangle centered at the origin with sides parallel to the axis. So basically you connect your vertices and co-vertices using a rectangle, and that's just the faster way of drawing the asymptotes. Obviously you can figure out the equations of the lines as using these formulas up here. But if you also want, you can just draw the rectangle and draw your lines going through those corners. So that's what this step 2 is telling you to do. Step 2 and 3, telling you how to draw the asymptotes using the rectangle method. And you draw the 2 branches of the hyperbola approaching these asymptotes. So then look at example 3. We did this one in class. We determined our vertices by looking at the equation. It's the number that's with x, so the vertices are on the x-axis, the co-vertices are on the y-axis, and we drew, the next step was to draw this rectangle, this little blue rectangle, connecting the vertices and co-vertices. So that's how we knew where the asymptotes were going to cross through. So notice that the asymptotes go from the center to each corner of that rectangle. And then from there you draw your hyperbola, which you see in red. And that they approach the asymptotes, but they never cross the asymptote. And then obviously at c units away from the center, we have our foci. So we calculate our foci. Sometimes it's not a whole number, sometimes it's a radical, but you can estimate your radical in order to graph it. So let's try another one, example 4. And what we notice with example 4 is that it's not set equal to 1, so we need to set our equation into standard form by dividing every term by 36. And what we end up with is y squared over 4 minus x squared over 9 equals 1. Determine whether it's horizontal or vertical. Well, the first term tells us this answer. So the first term tells us that y squared over 4, so it's vertical. The vertices are a units away from the center, so a, in this case, a squared equals 4, so a equals 2. And so our vertices are 0, 2, and 0, negative 2. Remember, since it's vertical, our vertices will be along the vertical axis or the y-axis. So there's 2 and negative 2. And we have our co-vertices, which we get from b. So b squared is 9. That means b is 3. And so our co-vertices are 3 units away from the center along the x-axis. So negative 3, 0, and 3, 0. Graph those. And let's draw our rectangle. And that's how we know where to draw our asymptotes. Our asymptotes go from the center to each corner of the rectangle. Doesn't have to be perfect, just kind of quick sketch there. As precise as you possibly can. Obviously, if you have a straight edge, you can draw these lines a lot more easily. And now the next step is to figure out the foci, because we don't want to forget the foci. C squared equals a squared plus b squared, 4 plus 9. which equals 13. Therefore, C is square root of 13, and which is approximately 3.5 when we graph. And so the actual points, though, are going to be along the y-axis in line with the vertices. So 0, comma, square root of 13, and or negative square root of 13, and then 0, comma, positive square root of 13. And I'm going to use a different color to draw the hyperbola just so you see it better. Oh, let's not forget our foci. So at 3.5, there you go. 3.5, there you go. So please pause this video as you're watching it so that you can draw along with me and have your notes done when I come back. Oops, I made a little mistake there. I used the foci to draw and not the vertices. Okay, let's try it one more time. From the vertex over, vertex over. Like two parabolas, right? We have two, one going positive, one going negative. And the foci should always be inside the curve. So, quick sketch just like that. There's another one. What happens, and here's the new stuff. That was all review from stuff we did in class yesterday. And this is what happens when we move our center A units right, H units and K units. So you know that it's minus and minus. The center is HK. Center at HK. And you know how to, it's going to be the same idea as we've done before. So you look at the parentheses and you take the opposite sign, and that will show you it. So you see that your center is +2 on the X and +3 on the Y. So it's the opposite of what you see in the parentheses, the opposite sign. Everything else applies just the same. So if you see the X term first, it's horizontal. So it's going to go through the horizontal axis. It's going to have its vertices on the horizontal axis, and look, it kind of looks like an H. So H for horizontal. Keep that in mind as you draw your hyperbola. So vertices here are A squared. Our A squared term is 16. That means A is 4. And so let's draw our center so we know where to put our vertices. So 2 units to the right and 3 units up. There's our center. And our vertices are going to be along the X value, along the same X, the new axis, right? Like, if that's the center, that's where we're traveling along that line, that X equals 2, I'm sorry, the Y equals 3 line. So if from here we need to go 4 units in either direction, we go 1, 2, 3, 4 is here, 4 to the left and 4 to the right. So our points here are 6, 3, and -2, 3. So we're adding and subtracting 4 units to our X value. That's what our vertex will do. Okay, let's write center. Or let's name it HK. And then so the co-vertices here are 3 units away from the center. So to the Y value, you're going to add and subtract 3 units. So we get a 2, and then add 3 to the Y value, same x value, subtract 3 from the y value. Visually, we go 3 units down and 3 units up. So there's the rectangle that we can draw. Draw your asymptotes. Let's find our foci. C squared equals A squared plus B squared. 16 plus 9 equals 25. C equals 5. And so from our center, we add and subtract 5 units. Let's add and subtract 5 units to our x value. So this is going to be 2 minus 5 is negative 3, and keep the same y value. 2 plus 5 is 7, keep the same y value. Draw your foci. We have a negative 3, so it's like 1 unit away from the vertices. Okay, let's draw the hyperbola. We have everything we need. So we go here and here. And the foci are inside the curve of the hyperbola. This question is asking us for the equations of the asymptotes. So if we, they're straight lines, so the linear equation is, excuse me. Okay, the equations of the asymptotes are y minus 3 equals 3/4 times x minus 2. The slope is 3/4. Because for a, let's go back to our notes, for a horizontal asymptote, it is negative and positive b over ax. So you just do the b over ax, and there it is, b over ax. Okay. That's going to be the end of this lesson, just moving the center around, but everything else kind of follows the same pattern. And we also had, you see a lot of similarities with moving the center that we had with ellipses. So try your best with this lesson, and we will review again when we get back. We will have a quiz on lessons 1 and 2 when we get back. You can practice for your quiz on MyLab. A lot of the questions will be very similar. And yeah, my biggest suggestion to you is to just go through this video, pause where you need to, fill in the notes, and then follow the steps when you're doing your homework examples. Okay, thank you, and I hope to see you soon. Bye-bye.